Welcome back to Raw BM 101, an introduction to bioinstrumentation. This will be the last subsection of this module, and we'll be talking about filters. In the last lecture, we talked about amplifiers, operational amplifiers, as well as the different types of operational amplifiers in relation to the golden rules. Each biopotential signal has a specific bandwidth, and biopotential amplifiers must be selective in the bandwidth that they choose. The specific bandwidth is then amplified, and other frequencies are attenuated, and this is called filtering. Filters can be either passive or active, and there are many different types, including high pass, low pass, band pass, and band stop filters, and we'll be discussing all of them in this chapter. First of all, let's talk about high pass filters. This passes signals above the cutoff point, FC. As seen on the graphs, once the point FC has been hit on this graph on the top right, this will cause a passband to occur, and all of the signals from that point on will pass by. However, below that point, any of the low frequency signals will not pass at all. In addition to that, there are two types of gains that can be seen. There's a decibel gain, which is calculated by multiplying the log of the V out over V in by a factor of 20, and a voltage gain, which is also V out over V in, but a much more convoluted equation, which is shown in the bottom left corner. The next type of filter that we'll be discussing is a low pass filter, which passes any signals below the cutoff point of FC. Similar to the high pass filter, but opposite, will eliminate any high frequency signals after the FC point. This can be seen in the top right graph, where after the FC point, the signal completely drops off. Gain is calculated the same way for the decibels, but is calculated in a different equation for voltage gain. Next is the bandpass filter. It is a combination of both a low pass and high pass filter. However, it uses both to calculate a middle ground, which is shown in the top right. The passband here has a almost square-like structure, and then from the left and right sides, it is being cut off by FL and FH, being the lower and higher frequencies. Similarly, there's the band stop filter, which is also known as the notch filter. It blocks and rejects frequencies that lie in between the two cutoff frequency points. So only the values between the lower and higher values are eliminated. However, everything else is kept. Thank you for watching this module over the introduction into bioinstruments. I hope you enjoyed it.